So the chain rule lets us take the derivative of a composite function. So without the chain rule, we can do these type of functions. With the chain rule, we can do composite functions. So now with the chain rule, we can add in a function that's more complicated. So what I have done with each of these functions is added an interior piece. And what I mean by that is where there used to just be x to the third, now there is 2x plus 4 to the third. Where the sine function just used to be x, now I have pi plus 2x. And where the square root was just x, now I have 2x plus 4. All of those that I have highlighted inside here with the chain rule, all three of these are our inside function of a composite function. Now, why is it called the chain rule? Let's take a look at the theorem. Okay, so what does all of this mean? What this means is if I have some function f of u, I can rewrite that function as a composite function where g of x is my inside part and I have my outside entire function. Well, what does this mean? This means that if I take the derivative with respect to x of this composite function, f of g of x, that is equal to the derivative of my outside function with respect to x times the derivative of my inside function with respect to x. Think about it this way. This is my y, correct? So to find the derivative of y with respect to x, first take the derivative of y with respect to u, which is my outside function. Then take the derivative of the inside function, which is my u, with respect to x. And this is a chain rule. If I had more functions inside g of x, this would go ahead and continue. We're now going to take the derivative of the three functions that I have up there in yellow using the chain rule. So again, the first thing to remember with this is you have an inside function and an outside function. The inside function here is my u. So I go ahead and say that u is equal to pi plus 2x. Now, if I want to go find d dx, then I need that du dx is equal to, now in this case, remember that pi is a constant. Pi is 3.14. So the derivative of a constant is just 0. Then the derivative of 2x is just 2. Now, let's look at the base function. Y is equal to the sine of u. Well, du is equal to just the cosine of u. But remember what u is. Again, u is my entire inside function. So that is my pi plus 2x. Now, putting it all together, what does this look like? It is y is equal to the sine of pi plus 2x. So the outside, take the derivative of the outside. So that is just y is equal to the cosine of everything on the inside stays the same. I'm taking the derivative only of the outside function here. Now I take and multiply that times the derivative of the inside, which is just 2. So y prime is equal to 2 times the cosine of pi plus 2x. Okay, so if we look at the first one I had there, it was y was equal to 3 times 2x plus 4 to the third plus 1. The first step is to see that this is f of x. And you have to identify the inside function, the composite function. And that composite function in this case is your 2x plus 4. Now we can go ahead and rewrite this as f of g of x is equal to 3 times that g of x plus 1. So I can take the derivative of the outside and I multiply that times the derivative of the inside. Again, the g of x is your inside function. So the outside portion, so the derivative of the outside is just y prime is equal to 3. Take the 3, multiply it times the 3 on the outside, times 3. Everything on the inside stays. That stays as g of x. It stays as 2x plus 4. Keep that the same. Subtract 1 from the exponent, that's 3 minus 1, or 2. And the derivative of your constant over here is just 1. Now, I take and multiply this times the derivative of g of x. Well, the derivative of g of x, or you can think about it as u, it doesn't matter how, is just 2x plus 1. The derivative of g of x is just 2. So all of this is just equal to 3 times the 2 at the end to give us 18 times 2x plus 4 quantity squared. All right, so with this function, the first thing I'm going to go ahead and do is rewrite the square root in terms of an exponent, which means that it's going to have 2x minus 4 to the 1/2 power plus 1. So to find the derivative of this, I take the derivative of the outside, which leaves me with 1/2. Everything on the inside stays. So that becomes and stays as 2x minus 4. But that 1/2 I have to subtract a 1 from. I do that in the form of 2 over 2. So all of that leaves me with negative 1/2. Now, finishing the function, the derivative of a constant is just 0, so I don't need it. Now the next step is I need the derivative of my inside function, 2x plus 4, which in this case again is just 2. So what I'm left with here is that the derivative of my function is equal to the 2 over 2 times my 2x minus 4 to the negative 1/2. That becomes 1, and I turn that exponent into a positive to make it to a positive 1/2, or 1 over the square root of 2x minus